Thank you everyone for showing up to the Simulation Composite Hangout for this week. My name is Dean Rose. I'm a support specialist here at Autodesk, and I've been working with the Simulation Composite Design product for several years now. Some of you may know it from its previous title as Composite Pro. And yeah, this is going to be building on the What's New Hangout I held several weeks ago, where we went into some of the new features for Composite Design 2015, and we'll be continuing on with some of the basic functionality of the program. And to go over, for those of you that are not familiar with the Hangout format, there's 30 minutes of discussion. I'll be going through some tips and tricks of the program, focusing on some of the features, and then afterwards we'll have some time allotted for anyone that has questions and answers, or questions. We'll be able to answer those live. And then during the session you can also use the side panel to ask any questions you may have, and we have a few people standing by to answer those questions. So go over a general overview of composite design and what it is. Composite design is a tool used to bridge the gap between engineering hand calculations and full-scale FEA. It's got a simple and intuitive design intended to allow you more time for exploring what-if scenarios constituting a large part of the design and analysis process. Today we're going to be covering the available material types within composite design. We'll also be going over a short review of what those material inputs are for each type. We'll be covering some available material resources you can research on your own if you need material data. We'll also, as we go through some of the inputs and material types, we'll be discussing the basic workflow. And then we'll be going over a Fabric Builder module. And then lastly, we'll go over sharing materials, what to do when you're creating and building your material database library. And composite design, we have only a limited number of required materials. But these materials are the foundation to everything that we're going to be doing from this point forward. So having accurate and reliable data points for your materials is critical to getting good results. I often hear customers asking, what do I do if I don't have a data point, or where do I get started for finding material data? So my goal with this presentation is to provide some guidance for inexperienced users and also enable the experienced user to tap the full potential of the program. Understanding the inputs used will significantly improve the analysis output. And from this point we'll jump into the program, and we'll just be walking through a live demo of some of the tools that we have available. This is Simulation Composite Design 2015. This is how you'll see it when you first install and open it up. On the left-hand side, you'll see a data tree. This is going to be populated with all the default materials that come included with Simulation Composite Design. There's fiber and matrix data, lamina data, core data, and the only field that's unpopulated is the laminates section. So we'll jump into creating some of these materials now. When you want to create a new material, you can go up to the New Item menu bar. And once you select it, it'll drop down with some of the available material types. We have fiber, matrix, lamina, lamina for Micromechanics tool, and also new core. And we're going to start by walking through each of these and look at some of the inputs that we have. So whenever you create a new material, you'll want to start by populating the name field. This is going to designate what your material is called. So we'll just name this the hangout fiber. And for those of you new to composites, fiber is essential for carrying the load in the composite. And you can see some of the input parameters we have are the Young's modulus for the 1-1 and 2-2 direction. The 1-1 is what we would consider the longitudinal fiber direction. We also have some shear moduli that are required inputs. Continuing down, we have Poisson ratios. And then as we walk down, you'll see on some of the materials that we're creating, there's some grayed out fields. And these fields are not necessarily required for every type of analysis. You can see here this is a CTE. These are the thermal expansion coefficients. And these would be only required if you're going to be doing some sort of thermal analysis. And then we also have moisture expansion coefficients in the 1 and 2 directions. And then we get to some required inputs. This is the tensile strength and compressive strength in the 1-1 direction. We also have the thermal conductivities for the material in the 1-1 and 2 direction. And then the last required input is density. And another option we have here is to export the material inputs to a Excel CSV file, and you can select that using this button here. We won't go through that feature today, but that is available. And we'll go ahead and close this. In order to cover the meat and potatoes of the functionality, I'm going to be focusing on what the inputs are and not necessarily inputting specific values. This way we can cover more material in a shorter amount of time. So we'll exit out of this. We're not going to be saving that. Next we'll go to the matrix material inputs. And for this we'll give it a name. And the matrix material's primary function is to transfer stresses between the fiber. The matrix also is intended to protect the fiber from mechanical and environmental damage. Some of the types of materials we have available by default with Simulation Mechanical are epoxies, phenolics, polyesters, vinyl esters, etc. If you would like to create your own matrix, we can do so through this new matrix window. Again, we'll see some of these familiar Young's modulus, shear modulus, Poisson ratios, very similar to the fiber inputs. One thing we'll see down here is the shear strength for this matrix material. And then lastly, the density. The same functionality at the bottom of the screen. If we'd like to save this, we can click Save. It'll save the material with this name and input it into the tree on the left-hand side. Next, we have the core material. And for the core, we don't have as many inputs. Primary purpose of a core material would be to increase the flexural stiffness of a laminate by effectively thickening it. These are commonly used in what we would refer to as a sandwich composite beam. And we'll go ahead and give this a name just to see the operation. And then some of these I get a lot of questions regarding what these actually are. They're covered in the online help documentation, but we'll walk through these now. This is the compressive modulus of the core material. And these are the shear moduli for the core material in the X and Y direction, or a specified length and width. When you use this material in your sandwich analysis, there's some good graphics that will show you how those are being applied. And then next common question is the density of the core material. So this is density of the core, not just the material being used for the core. Those two can be different values, so we want to make sure we're using the actual density of the core itself. We also have diameter of the cell, commonly used in the honeycomb cores, and then we also have the core cell wall thickness, and those are all required inputs. So we can export those. For now, we'll just close this. And next, we'll be looking at creating a lamina. And a lamina is the basic building block for your laminate. These values can be input directly using this tool, or we can also calculate them from the fiber and matrix constituents using micromechanics. And we'll go through the basic process here and cover a quick tip for those of you that may be missing some of these data points. So we can select the lamina. We can assign it as a unidirectional type, woven type, or random mat. We can also give it a fiber volume fraction. We can assign a thickness. And then we get into our Young's moduli for each of the directions. You'll see this is more fully populated than the matrix or fibers that we were looking at earlier. We also have the 3 Poisson ratios. And then we'll go into the thermal expansion coefficients, moisture expansion coefficients, and then you can see we have quite a few strength values. And then we have the strain to failure inputs. We have thermal conductivity for each direction, 1, 2, and 3. And then lastly, we have density. Keep in mind these grade values here are not required inputs for most of the analyses, but if you're going to be doing some sort of a thermal analysis, you'll want to input those. And one of the questions we get a lot is, what can I do if I'm looking at my material data sheet and I don't see this E33 value, or I'm not seeing a new 2-3 value? One of the things we can do, if you have your fiber and matrix data, we'll go ahead and use the pre-populated fiber and matrix, and we'll select S2 fiberglass and a polyester, and we'll go ahead and drop this fiber volume down. And you can see when you adjust this slider here, it's going to increase this value and decrease this value appropriately to keep it to a total of 100%. And then we just click calculate. And using the micromechanics, it's going to go ahead and calculate all the lamina properties for your materials. So if you have a material data sheet and you know some of these values and you're missing a few of them, you can either go over here, grab this value, and input it where your missing value is. And this can complete your definition. Or you can go ahead and save this lamina by itself, and it already has all these values. This is a quick time saver if you don't have the material data sheet for your lamina, but you have your fiber and matrix data. So we'll go ahead, save this. Just input your name, click OK. And on the left-hand side here, you'll see down at the bottom, it's populated on our tree, Hangout Lamina. You can also close this and then reopen it, and you can see all the data points are saved. And that's good for going back and doing iterations on your material. And covering the information where we discussed about not having some of those data points, we often get the question, where do I go to find some of this material data? And there's a few websites you can look at. I'm sure some of you, if you work in a large company with lots of resources, you probably have your own internal data research and development teams that can build your composites, run them through the gamut of testing to get your material data points that you're looking for. Some of you that may be working for smaller companies probably don't have access to that, and you need to depend on other people, either through some external testing or through data verification that's been done in research papers. A great website that's been available for some time is Prospector Composites, and you can log in there. You can pay for data sheets, search through their database, and find quite a wide range of fibers, matrix, and lamina, as well as laminate data. So that's a great resource. You can also search through research papers just by searching through Google, utilizing that tool, or you can search directly through ScienceDirect, Sage. There's a few others that I can't recall at this time, but there's a lot of available resources for published information out there. You can also look through some ASTM publications, books, information that's been done on composites. And then lastly, we have some government publications that are available. NASA, MilSpec 17, NIAR has a great website. You can log in there, view their materials that they have. They have a lot of A basis and B basis data, and you can also get on a mailing list. They'll send you updates. I think it's bi-monthly. That's also a great tool. And then just using the internet, keep in mind manufacturers also make data available. You want to kind of take that with a grain of salt. It's often very limited in what they're going to give you. And then there's also some questions as to how reliable that data is. They don't give you any sort of background on the testing a lot of the time, any sort of thermal conditions and environments that they're testing it in. It's usually just a very generic set of data. So keep that in mind. You want to have good quality inputs when you're building your materials, because those are going to be called upon later on, either through the fabric builder or through the lamina for micromechanics, and then onwards and upward to the sandwich and beam plate analyses that we're going to cover in a further hangout. And then next, we'll go to creating a laminate. And we'll go back into the program here, and we'll walk through creating the laminate. We've covered the lamina values, and now the laminate is basically a bonded stack of laminae with various orientations of principal material directions. So we'll go to the new item, new laminate, and we can create a laminate name. If we have other previously created laminates, you can also use this open button, and it will open the laminate and populate this area with all the plies, thicknesses, and orientation angles. And since we don't have any, we'll go ahead and create one. We'll go ahead and we'll use the Hangout lamina we created. We'll assign it a thickness and an orientation. We can select that row, click repeat. We can also make it symmetric. We can change these angles, orientation angles. We can select all 4 of these, click symmetric, and you can see what's going on there. You can also go through, if you want to change this lamina, you can select a different value here, and it gives you a lot of flexibility for your analysis, whatever you're trying to do. So, and this laminate will be used in the plate, sandwich, and tube beam modules later on. And this covers the new laminate tool that we have. we'll go ahead and, oh, we have some 0 values in here, so we'll go ahead and populate those. Anything that you don't populate here, it's going to give you a warning message if it's required, so it won't allow you to save some blank data that could cause an error down the road. So now that we've created a lamina and a laminate, we can see these over here in our tree. Sometimes in order to clean this up, what we can do is go up here to the data menu, select sort file tree. We can also access this through the file menu. Select sort file tree. It'll ask us if we wish to continue. It's going to sort our materials, and now it's going to alphabetize them so we can find them easier later on. Now we're going to jump in the last portion of our material creation, and this is accessible through the Utilities menu, and it's called Fabric Builder. This has a number of options, and it's quite a large tool, so there's a lot of discovery here for you if you're interested. We have the ability to create a random continuous mat, woven fabric, or stitched fabric. For this demonstration, we'll walk through the random continuous mat and demonstrate what's going on behind the scenes and give you a little insight into the output. So we're going to be doing kind of a micromechanics model here. We'll select boron and polyester, and we'll go ahead and put an aerial weight in there. I'm not sure if that's what the actual data point is, but we'll go ahead and use that. And we'll go ahead and decrease this down to 45. We'll leave the void volume at 0. And we can click Next. You can also navigate back if you want to change something or feel you've made a mistake. This is going to go ahead and calculate your fabric thickness in inches and give you 2 options here on how we're going to proceed in creating our fabric lamina strengths. You can select micromechanics, which is the default, or choose selected lamina. For micromechanics, we're actually going to do a progressive failure and get some outputs. And then selected lamina, you're going to be able to select one of the lamina that you've created and use those strength values for this new lamina. We'll go ahead and leave it at micromechanics. We'll stick with the default of maximum stress. You can change these. We'll give you slightly different outputs, but a very similar format. And it looks like we have some infinite stress here, so we'll go ahead, select a different material. And we can see here, using that AS4, we're given 3 different values for the X tension strength. And what we can do is, using this resin tension, that's going to be a very conservative approach. This is similar to kind of the first ply failure. And then we also have this fiber tension value that's given. This is a more aggressive strength value, more closely related to the ultimate strength of the composite. So let's go ahead and be fairly conservative. We'll choose this resin tension and ply 4. Maybe even go with the ply 5. Play it safe. And this is going to walk us through all the strength calculations for the various directions: X tensile and compression, Y tensile and compression, and then a shear strength. Now we're in the Y field. Go ahead and select that. And now it gives us the opportunity to name our fabric. Go ahead and click Next. It's going to give us the option to append this to an existing laminate or just save it as a completely new laminate, a lamina. So we'll go ahead and save it as a new lamina. And here we can see the fabric builder, that lamina that we've just created. And it's going to pull these strengths from the inputs that we selected through the fabric builder module. So this concludes the demonstration for creating materials. Now we're going to jump into managing the materials. Some of these topics are all coming from common questions that we get on the support side, and we often have people that are either upgrading from an older version on maybe an outdated computer that's going to be sent to the dump, or they're trying to share materials with an associate. So we're going to go through some of the options you have. First, we'll start with sort. We've already covered sorting the file tree. That's a good one to keep all your materials organized so you can easily find them. And next we'll go to preferences. This is going to be where your data source is living. By default, when you install Simulation Composite Design, this is where your data directory is going to live. So for this scenario, I have my associate who has some materials in his library. He's maybe shared them on a network drive, or maybe they're just on his local machine. To simulate that, we're going to go to another directory. And this is just a directory on my machine where I've saved some materials. Go ahead and hit Enter. And we'll see the same structure format where we have a data folder and we're looking for this .data file, and that's available through the selection here by default. We'll go ahead and select that, click Open, and now you'll see the data source for all of our material tree. We'll click OK, and now we're going to see that these materials have changed slightly. We still have the default material properties, or materials. I've just copied those over, and then I've also created a few additional laminas here just to demonstrate. This one only exists in the secondary share, so we can see that the data tree has changed. We don't have the laminates anymore. So now what we want to do, say we just have one material that an associate has created and we want to use that in our analysis. So we can go up here to import file. We can also import entire directories. For now we'll do importing a file, and it's going to ask us for the location of the file and the type of file to import. Unless you're using a very, very old version of Composite Pro 3, you'll want to go ahead and leave this as Simulation Composite Design. Some of you may be using Composite Pro 4, 4.2. This is also valid for that. We'll click on the Browse folder, and here we can see a number of thickness, angle, fibers, matrix, lamina. These are all signified by this extension type. We'll go ahead, we can select a fiber, and this is pulling from our source directory. So if we want to go back to our other library, we'll go ahead, select Open. So now, oh, didn't work quite as I planned. So now we're back in our main source default installation, and we can see some of the lamina materials that we created. Here we have that hangout lamina we created. We can go ahead, select that, click Open, and now we'll import it. And we can go into here, and we can see that this hangout lamina has been imported from our other library. So it's a great way to consolidate materials across the board, across all users. You can also point that source in your preferences to a network share. So if you have multiple users creating data and you want to share that amongst the whole team, you can just keep that on a network share. You also have the option of importing an entire directory, very similar to importing a file. Instead, we'll just be navigating to that data directory and importing all the files, and it'll give you a pass-fail status at the end. And then lastly, we often get a lot of questions about creating materials via a script. Some of you may be familiar with Python or other scripting languages, and you have a number of material data points. You'd like to create them quickly without going through the interface and selecting new fiber, inputting all these data points, and just maybe possibly modifying the elastic modulus in the 1-1 direction for a parametric study. There is an ability to, for those of you that are advanced and have some programming knowledge, you can create these materials and save them that way. We don't fully support this, but just wanted to let you guys know that it is available and can be done. The one thing that you'll probably run into is creation of the GUID. Each of these materials, when it's saved in the material directory, has a unique identifier, and that's one of the common questions we get when users are trying to create their own custom materials. And this covers everything that I have for the Simulation Composite Hangout. I want to thank everyone for coming today. We'll be available for a short question and answer session at this time. And any questions we aren't able to answer, we'll be able to follow up with you at a later date. And in addition, we'll also have a YouTube link being sent out for those of you that weren't able to attend. You'll be able to watch this video and revisit some of the points that we've covered. And if you're satisfied, feel free to log off at this time. If not, we'll be looking through some of the questions and having some of our team answer those for you. All right, thank you, everyone.